You are all welcome to second AI Expo Tokyo Big Site Japan. Let's spend a few minutes to understand what Macnica.ai is and how Macnica.ai could be your partner in global AI revolution. How we are going to help our enterprise customers and enterprises, businesses in Japan by providing AI solution going forward. Avkar Chauhan, and I'm currently head of AI platforms and businesses at Macnica Networks. Before that, I had positions in H2O.ai, Big Data Perspective, Microsoft, and ISR. If I try to introduce myself with my career in IT, I would say I started my career with a company called ISR. Headquarter was in Tokyo, Japan, but I was working mostly from Silicon Valley, Foster City, California. My role was software engineer, and I worked there about 4 years from 2001 to 2005. After that, I went to Seattle working at Microsoft. I spent about 8 years over there working with Fortune 500 customers and various telecom companies in Asia. I did started as in Windows 18, but I was very early engineer in Windows Azure, and I was the key contributor to build HD Insight project over there at Microsoft. I left Microsoft 2013, joined a company called Platfora in Silicon Valley, where I worked with the various financial and government sector to deploy Platfora big data appliance to do the super large scale intelligence. After that, I had my own company called Big Data Perspective, which I founded. I took money from investors and I ran that company about 2.5 years, and where I had opportunity to work with very large scale big data software providers such as Cloudera, Huttonworks, Mapper, and various others. I built an appliance which was designed to understand the workload happening on a big, large data clusters and identify any problems using anomaly detection, use with deep learning autoencoders, and then heal them as well. That company was acquired by Ninja RMM. Then I joined one of the leading machine learning organization in H2O in Silicon Valley named H2O, where I was heading their products and customers. During that time, I had opportunity to work with really very large organization in various industry. And finally, currently, I am at Macnica.ai, leading their AI platforms and businesses, especially for Japanese customers first. Working about 17 or 18 years in various IT industries gave me experience within the variety of industries such as retail, healthcare, marketing, finance, insurance, telecom, IT software, and IoT recently with IoT and IoT. It gives me opportunity to really talk about various things happening in various industry and how artificial intelligence is really going to solve problems within those industry as well. Okay, so very first thing when we talk about implementing AI solutions in your organization is a brand new thinking. You really have to think about data as a product. Very large organizations in last 5 to 10 years have created billions of dollar businesses by thinking data as a product. It is very important for any organization to take a look at their data storing strategy, how data is really being used, collected in a company, and how they can use this data to really build products around it to generate new revenue streams. So what you really do, you collect all that data, you refine the data and put that data into a machine learning system, a machine learning pipeline which generate a model. Basically, a model is the overall learning from your data which can be used to predict newer results when the newer data is really available. Once your model is ready, you can use that model and apply that model in everywhere where you would really want to generate actionable intelligence. And now once you have that model available, you can actually use replace everywhere where you have rule based system, and you can apply these models which are even more smarter as we progress further, and you can pretty much remove the rule based engines in your organizations by replacing them with newly created models. So you have data, you have generated model, and now model becomes a currency for you. Basically, it's a new source of revenue for any organizations going forward. And that's basically essential for any organization to look into data as their new strategy, where they can use this data to monetize in newer ways in this economy or even going forward. So, what is AI, and why you would really want to use AI in your business? If we look full spectrum of AI, we can really understand variety of ways you can apply AI in your organization. You can actually use AI to create a new line of businesses, new line of solutions. You can also use AI for business process optimizations. And finally, AI is really being used in larger organizations for major cost saving methods. Organization of any size, whether it's small, 4 or 5 person team, or it's a very large organization with having hundreds, thousands of employees, they all can take advantage of artificial intelligence in a variety of ways. And here you could see that various organizations at various stages can take advantage of artificial intelligence in their business. If they are really creating new line of business application using AI, they can be considered as innovators, early adopters, versus business process optimization is mostly for medium-sized businesses because they do have various business processes and they really want to optimize with artificial intelligence. And for very large organization where various aspects of cost saving methods can be applied with artificial intelligence as well. So no matter what size of organization you are, you do have applications of AI in your business. And now we can take a look to see how you can make AI working in your organizations, what kind of projects you can choose depending on what your artificial intelligence need is. Here you could see that new line of businesses applications are basically they are low cost to develop. They are really having lower complexity as well as the really smallest time to develop. The reason is that new level of businesses have less interaction or less complication to really start with. It is because newer thinking and all the teams which are involved can very quickly put together a solution which is ready to start, ready to work, and and businesses ready to take advantage. Versus business process optimization or cost saving, they are fairly little complex to develop and takes time, and cost saving methods are why they are complex or higher time to develop is that there are various teams involved, various data functions, various I would say authorizations are needed in order to access the data, which really basically put a lot more complexity and time to develop the solution for that regard. So if you are an organization and you are looking for AI to solve your problem, basically you find if there are any businesses where AI can be applied, which means that you can get solutions done in short amount of time with very small cost. And then once you start taking advantage of AI, then you can start going upper and higher level of problem solving with AI. So now let's spend some time about the machine learning life cycle and then how it is really being improved in Silicon Valley. So for last 20, 30 years, even more, machine learning is really popular in insurance industry for over 40, 50 years. So basically the machine learning life cycle consists of 3 steps: data ingest, once data is ingested, model is really being built, and once model is built and a final model which is ready, which can be put in production, that model is really put in production, so you start generating results and companies start taking advantage of those results. While new data is coming, then new model is built and check for accuracy. If accuracy is higher, then higher accuracy model is put in production, and that model is basically generating the results. So that's the 360 view, or the life cycle of machine learning in any organization. Now we will really look into that how the fully automated system of AI can be generated for any business, whether the business is really very small or it's really super large. The process of basically putting together an AI machine learning pipeline is going to be almost same with just a few modifications. So everything starts with data. You really have to collect data from various streams, put together, clean it, make sure it's machine learning ready. And once machine learning ready data is available, you can put this inside in a machine learning system where basically that data is really ingested. Once the data is ingested, we really need to understand to make sure that data is really machine learning ready. Is there any problem or not? If then data visualization and the data validation techniques are really used, which can understand, which can understand and explain if there are any issue with the data. So once a data scientist or a system is really understood that there are no further issue with the data, that data is really ready to go for machine learning engine, and that basically that data is really being fed into a machine learning system, which is fully autonomous system, which basically take the data and start feature engineering using genetic algorithm or maybe some other advanced technology. And in the automated feature engineering process, basically the newer and newer features are generated based on a given data set, and machine learning models are built using some kind of sampling method. During this process, both automated feature engineering and scalable machine learning work side by side. New features are generated, new models are built, models are evaluated, and new features are checked. If features are good, models that helps to build a more accurate model, then those features are kept. Otherwise, those features are dropped. This process runs for several minute to several hours, depending on how this whole scalable automated AI system is really being configured. And once everything is really completed, and this process of automated machine learning and skill is automated feature engineering and scalable machine learning, a final model is really generated, which is a most accurate model this system can produce at this given time. This model is basically ready to put into production, and if you would like, you can actually apply the machine learning interpretability to explain the results, which really helps business process business leaders to understand why the model is results are given as such. And finally, if you would like, you can take this model and you can really extract uh, from the system and deploy it wherever is really needed, in Python, Java, or any other environment, and where this model is really start generating its codes for the given data. So that's about a very standard automated AI system, which is really being used for to not only for rapid prototyping, but also to build models at a really very fast scale. And to make this whole thing process basically is very speedy. The GPUs are really being used at maybe feature engineering scale, or could be in machine learning stage, or could be both. So it's depend on the engine which you are really using for this purpose, and it's all depend on how that is really engine underneath is really designed to support GPU or not. But basically GPUs are really being used with various machine learning engines to expedite this model building process. Now we can spend some time to understand what is machine learning development lifecycle is. And in order to understand machine learning development lifecycle, we start from data. So various organizations have data in various locations, in various silos. So really you need to put together a data engineering team which can merge this data, make it machine learning ready, so that data can be used by machine learning systems or machine learning pipeline for your organization. There could be various machine learning pipeline for solving a various machine learning problem. However, the data which is really coming out from various different sources has to be merged together in order to make the best accurate model with regard to the machine learning problem you are really going to solve with. Once that data is ready, that data is really being fed into a machine learning system. And if we look into machine learning is a two-part process. Is a building machine learning as well as the applying machine learning. When we look into the building machine learning, which is primarily a data science job, however, it does require software engineering. So we can say it's a 75, 20, 25 or 80-20% distribution between data science and software engineering to build machine learning models. Versus applying machine learning is a purely software engineering job where you work with IT to put together a model in production and newer data is really being scored against the model. If we look into what data science teams are really doing, their job is basically to use various different machine learning engines, machine learning algorithms, hyperparameters, and optimize create a whole process of optimization where thousands and thousands of models are being built, and then finally the highest accurate model is really being available, put together, where IT or software engineers can deploy that model in production. While this thing is really going on, we can really take a look is that what this model is really being deployment, what model deployment means really. So basically when we talk about model deployment, we are talking about the learning which came out from data is really being deployed for newer to generate newer results. So business teams can really take advantage of. Here you could see that model that could be deployed on edge, such as smartphone, web, IoT devices, factory, cars, and these models are basically generating scores, results, which can be fed into business processes. If we look into what software engineers role could be in building machine learning, basically they are the one who put together these automated machine learning systems or build such as a driverless AI component or systems where you can really feed the data, and after several hours of machine learning you really get a machine learning model without even knowing what had happened underneath. A key advances in machine learning is a rapid prototyping, where you have data you can feed to an engine and you will get one of the best accurate model it can provide, and this model is really ready to put in production. So that's we call it rapid prototyping. For some of them it could be considered as a black box. For some it's really good to have a black box because they really do not want to understand the integrate complex methods and technology inside machine learning. They just want to use machine learning as a tool. For them, just loading the data and after processing getting the results are enough. While others, this black box may not be useful, they really want to understand. So for those who really think that they really need to know more about what is happening in rapid prototyping, they can basically look into inside, which is what is happening. And if we look into deep inside, we can see that basically the rapid prototyping is a data transformation, which is mostly is a feature engineering, building multiple features, multiple useful features from the given data, and then building various states of models and understanding that how those models are really getting accurate higher and higher, and just keep that and keep building them until they really find the best model. Once the model is ready, MLI, which stands for machine learning interpretability, is really used to explain the model. And H2O software such as driverless AI is one example of rapid prototyping where without even knowing anything about complex intricate learnings about machine learning, you just really can use this software to import your data, load into driverless AI, and just get the best available model as a base model for you to start with. We can if we talk about the MLI. MLI is basically making the AI ready for businesses. So for the regulated industry, if you would like to use artificial intelligence, MLI is something which is going to make it really possible, where the regulators can really understand the explanation provided by MLI regarding the model which really produce the results. There are various ways MLI can be implemented, such as decision trees, partial dependency plots, variable importance, and lime k-lime methods. Basically, these methods explain the results produced by machine learning models when user scores them, and these explanations are business ready, means business people can very easily understand them and make sense that why the model results are such as what is really given for you. And MLI is a growing field. Several researchers are actually working. H2O driverless AI uses MLI to explain the results, make machine learning ready for businesses. Once rapid prototyping is done, models are ready, and MLI is ready to explain those models. You have ability to very quickly understand those results. Your business people can understand the results and make sure that model is really can be deployed in the production. For any organization of any size, we can take a look how AI adoption strategy can be finalized. Here in this slide, you could see that left side where the organizations are in no voice in terms of data science and artificial intelligence, versus on your right the organizations with the expertise, full expertise in data science and artificial intelligence. And if you look into this spectrum, the initial stage of data science or machine learning, basically you really have a lot heavy data science versus less software engineering, versus the other side of other sides of AI is more of implementation of data science, so which is like heavily on software engineering and lower on data science. So if you are an organization with a team of data scientists and software engineers, you can really understand what is really needed in order to build a successful artificial intelligence project in your organization. What kind of team you needed, what knowledge capital you really need in order to put together the whole project working. So as an organization, you really need to understand where you are, what kind of help you really needed, whether you really need to have assistance from data scientist point of view, or you really need assistance from software engineering point of view, or you really want to take advantage of data scientist and software engineering from a third party organization. So once you identify where you are, where your needs are, you can really have a partner who will be able to helpful once you identify your need. But identifying the need is very important to for you, so that you can really find a best suitable partner for your AI adoption strategy in the organization to solve one or multiple problems with artificial intelligence. So that's all I had to share with you. I really appreciate your time. I'm glad that you came to our booth and you spent some time while learning how we can help you. Please do reach out to me at my email afkosh@macnica.com, or if you think that we could helpful for your project, for your AI strategy to implement AI solution in your organization, please contact us, Macnica, and we'll be very happy to provide our assistance to you. Once again, I really appreciate your time. Thank you so much.